Good morning, students. In the previous class, we see some problem involving set relations and functions. Now we continue the remaining problems. We already know the formula, but I remind the formula. The first one is n of p of a. How to read? In 10th standard also we see the one. N of p of a means the number of elements in the power set of a. Okay, n of p of a. The general formula is 2 power n of a. If a is indicates, then we write it is 2 power n of a. Suppose if it is a b, then we write it is 2 power n of b. N of p of a means number of elements in the power set of a. Power set, it contains all elements, empty set, full set and all subsets. So n of p of a formula is 2 power n of a. Now we introduce a new one. Is a set difference of that two sets, A delta B, or it should be read it as A del B. The set difference or the symmetric difference. A minus B means a set difference. A delta B means it is a symmetric difference. So the symmetric difference of A and B. A union B minus of A intersection B. We introduce a new formula. The symmetric difference of these two sets A and B. A delta B, or it should be read it as A del B. A union B minus A intersection B. Suppose we need the number of elements n of A del B. So what is the formula? A del B is the formula. So n of A del B formula is n of A union B minus n of A intersection B. Now we use this formula in the remaining problems. So first I indicate the formulas. So n of p of a, number of elements in the power set formula is general formula is 2 power n of a. And the symmetric difference is not a difference, it's a symmetric difference between these two sets A del B. Formula is first of all union minus second of all intersection. Now we move the next one. It's the sixth one problem. N of p of a is 1024. N of A union B is 15. And n of p of b is equal to 32. Then our question is find n of A intersection B. You see these two terms, n of A union B, to find n of A intersection B. In this two term involve one formula we already know. The formula is the addition theorem. N of A union B is equal to n of A plus n of B minus n of A intersection B. So we need n of A and n of B directly is not given, but some power set is given. So using this power set, first we find n of A and n of B. Given first of all, n of p of A is equal to 1024. We know very well 1024 is a multiple of 2. In how many times we multiply 2 we get 1024? It's 10 times. The value of 2 power 10 is 1024. That means 2 to the 4, 4 to the 8, 8 to the 16. We go up to the 10 times, we get 1024. But we already write the formula. N of p of A formula is 2 power n of A. Therefore, what about n of A? We compare these two. N of p of A, n of p of A. In place of 2. In place of n of A here, 10. So n of A value is 10. So first step we find the value of n of A. Also, one more data is given. N of p of B is given 32. N of p of B, how to read? Number of elements in the power set of B. So n of p of B is equal to 32. How to write 32 in 2 powers? Because this formula is 2 power. So we write a 32 as 2 power 5. 2 to the 4, 4 to the 8, 8 to the 16, 16 to the 32. So we multiply 5 times. So 2 power 5. Then directly we write n of b. You know very well. Then directly we write the value of n of b. The value of n of b, what is the power of 2? The value of 2 power 5 is the. So n of b value is 5. So first we find n of a and n of b. Because we find that value using these two terms. This two term is already we find. Then we using one formula. So n of p of b is given using this data to find n of a and n of b. Next we write the known formula. n of A union B. The formula of n of A union B is n of A plus n of B minus n of A intersection B. We already know the formula. Now in this formula we substitute the known values. So what are the known values? N of A union B, that value is given. The value is 15. N of A, we already find. The value of N of A is 10. Plus N of B is 5. Minus N of A intersection B. So 15. 10 plus 5 is also 15. Minus N of A intersection B. We need that term only. So what is the value? The value is just 0. So N of A intersection B, okay, the minus will become that side, plus is equal to, already 15 is the plus 15 becomes that side, minus 15. So N of A intersection B value is equal to 15 minus 15 is 0. So N of A intersection B value is 0. Our question also to find N of A intersection B. So that value is 0. So what is the relation of this A and B? So these two sets are mutually exclusive. So 0 means there is no common elements. But our question is to find that value only. One more questions. What is the relation of these two sets A and B means these two sets are mutually exclusive because no common elements. N of A intersection B is equal to 0 means A intersection B is an empty set. So number of elements in A intersection B is equal to 0. So the value of N of A intersection B is equal to 0. Now we move the next one, the seventh. If N of A intersection B is equal to 3 and N of A union B is equal to 10, then find, how to read, N of P of A, the symmetric difference of B, or it should be read it as P of A del B. We already know the formula. N of P of A del B formula is 2 power N of A del B. So to find, first of all, N of A del B. Now first of all we write the formula. We already tell this formula. N of A del B. In the previous class we introduced the formula. So the formula of N of A del B is equal to N of A union B minus N of A intersection B. N of A union B, that value is given. That value is 10. Minus N of A intersection B, that value is also given, is 3. So N of A del B, that value is 7. But our question is not to find the N of A del B, to find N of P of A del B. Therefore, N of P of A del B. Actually, what is the formula? The formula is 2 power N of A del B. Okay, the formula of the power set is 2 power N of this A del B. 2 power, we already find the value of N of A del B. The value of N of A del B is 7. Therefore, N of P of A delta B value is, what is the value of 2 power 7? We multiply 2 7 times. The value is 128. We check the value is 128. 2 power 7. We multiply 2 7 times. 2 to the 4, 8, 16, 32, 64, 128. So the value is 128. Now the next one, 8.1. For a set A cross A contains 16 elements. And 2 of its elements are 1, 3 and 0, 2. Then find the elements of A. That is, A is a one set. And the Cartesian product A cross A contains how many elements is important? 16 elements. And 2 of its elements, totally 16 elements is there. Out of the 16, 2 elements is given. The values are 1, 3 and 0, 2. Then our question is, find the elements of A. What are the elements A? A are how many elements? First of all, given N of A cross A. is equal to 16. N of A cross A means the number of elements in A cross A is equal to 16 also. Two elements is given, 1, 3, 0, 2 is belongs to A cross E. 1, 3 and 0, 2 belongs to A cross A. So in a Cartesian product we write one pair. The first element lies in the first set, the second element lies in the second set. But here both are the same set, A. So this element lies in A and that element is also lies in A. So now we come to the conclusion, then A contains how many values? Therefore, the value of A is equal to 1 lies in A, 3 lies in A, 0 lies in A and 2 is also lies in A. All the elements are lies in A and also all the elements are distinct. So we write the value of A in ascending order. The least value is 0. Next value is 1, 2, 3. So A contains just 4 values. 0, 1, 2 and 3. It satisfies A cross A is equal to 16. We find the Cartesian product of the same sets A cross A. A value cross again the same value. So first set contains 4 values. Second set is also contains 4 values. So 4 4s are 16. So N of A cross A is 16. We find the Cartesian product of A cross A. This 2 value is also occur. So using this data, the values of A is 0, 1, 2 and 3. The sum is easy because the given elements are distinct. Suppose the same number of elements is occur. Here also 1, 2. Then we find the Cartesian product of these two sets. Then only we find the values of E. Here all the elements are distinct. Therefore A contains 4 values. The values is from 0 up to 3. That is 0, 1, 2, 3. The next question is, let A and B be two sets. A, B, two sets such that N of A is 3 and N of B is equal to 2. That means A contains 3 elements and B contains 2 elements. If x, 1, y, 2 and z, 1 are in A cross B. Then our question is, find A and B is given x, y, z are distinct elements. So this x, y and z are in distinct elements. First of all, we use some data given N of A is equal to 3. N of B is equal to 2. So A contains 3 elements and B contains 2 elements. Now to find the 3 elements of A and the 2 elements of B. Also, some of pair is given are in A cross B. So also x, 1, y, 2, z, 1 is belongs to A cross B. This ordered pair is belongs to the Cartesian product of these two sets A cross B. So the nature of A cross B of in the ordered pair is always the first element lies in the first set and the second element it should be lies in the second set. 1, 2 and 3 pair is given. So many pair is also come, but 1, 3 pair is given, it belongs to A cross B. Now to find each and every pair. So now we come to the conclusion. Therefore, A contains how many elements and B contains how many elements? Already given, N of A is equal to 3. So the first one is always lies in the first set. So I say X is lies in the first set A, Y lies in the first set A, and Z is lies in the first set A. So the value of A is X, Y, Z. Okay. Next B. What are the values of B? In an ordered pair, the second element is always lies in the second set. So 1, 2, just 2 elements I say. So one more one is there, sir. Yes. Because this is a Cartesian product, so many values is possible. So many ordered pair. How many ordered pair is possible? 3, 2. 3, 2, 7, 6. It's given x, y, z are distinct elements. So we Cartesian product of these two sets, final value is x comma 1 is there. Next value x comma 2 is not given. And y comma 1, y comma 2. Z comma 1, z comma 2. We also given n of a is 3. Okay, now we count 1, 2, 3. So n of a is 3. B contains 2 elements. So n of b is 2, so the value of b is 1 comma 2. Out of 6 ordered pair, 3 ordered pair is given. So using this 3 ordered pair, we will take the values of a and b. So the value of a is x, y, z. And the value of b is just 1 comma 2. We don't write the repeated terms, because the total number of values of n of b is just 2. So a value is x comma y comma z, and the value of b is 1 comma 2. The next question is the 10th one. If a cross a has 16 elements, the Cartesian product of these two sets has 16 elements, and one set is defined as S is a set. It contains ordered pair a comma b. It belongs to a cross a. So the ordered pair is belongs to the Cartesian product of the two same sets, but important it satisfies some conditions such that a less than b. That is, in ordered pair, the first value is always less to the second one. Okay, a comma b is such that a is less than b. I say one element of this set is 1 comma 2 is possible, because the first element 1 is less than 2, so it belongs to S. Suppose whose reverse 2 comma 1 is does not belongs to S, because the first element is big compared to the second element. Now to find the values of this S. Also given our 2 ordered pair minus 1 comma 2 and 0 comma 1 are 2 elements of S. You see these 2 elements minus 1 comma 2. First element is less compared to the second one. 0 comma 1. First element is less to the second one. Then our question is, then write the remaining elements of S. We don't write all the elements. In S, we find some remaining elements. That is the remaining ordered pair. 2 ordered pair is given. Now to find some more ordered pair, it satisfies this condition. Okay. First of all, we find all ordered pair. Given A cross A has how many elements? 16 elements. Given n of A cross A is equal to 16. So in this condition, I come on conclusion, n of A contains how many elements? Both are the same sets. So the number of elements is also same. So the Cartesian product of all values is 16 means, so each and every set has 4 values, because 4 fours are only 16. So n of A value is equal to 4. First we identify the values of A. So I write n of A is equal to 4. This is possible only when both the sets are same. Suppose the sets are differ, A cross B. So A value and B value is different values. Suppose both have the same sets and also is exactly 16. So only chance is n of A is equal to 4. So A contains just 4 elements. Also 2 elements of S is given, minus 1 comma 2 and 0 comma 1. This 2 element is also lies in A cross A, and also is lies in S also. Okay, in A cross A all values is there. Especially this 2 value is also lies in S. But we will take this value is first of all the Cartesian product of these 2 sets. Therefore, I come on conclusion, the value of A is, you see each and every values are distinct. Minus 1, 2, 0, 1. We already said in an ordered pair, the first element lies in the first set and second element lies in the second set. But here both the sets are same. So minus 1 lies in A, 2 lies in A, 0 lies in A, and 1 is also lies in A. We write in ascending order, what is the least value of among this? Is minus 1. Next value is 0, 1, 2. So A contains these 4 values. We already tell n of A is just 4 values. So the 4 values are -1, 0, 1 and 2. So now we find the Cartesian product of these two sets, A cross A. -1, 0, 1, 2 is set A cross again A. -1, 0, 1, 2. Now we write the Cartesian product of these two sets. I write in one by one. We know very well how to write the Cartesian product of two sets. First we take that element -1. Then we write this element -1. Next, we don't change the first set element. We move the second set elements. So -1. The next element of -1 is 0. -1, comma 1. -1, comma 2. -1, comma -1. -1, comma 0. -1, comma 1. -1, comma 2. Over. Now we move this element and also we move the next one. So the second set is 0, comma -1. So -1, the next number is 0. So in all the ordered pair, just we remove -1 and we add 0. 0, comma 0, 0, comma 1, 0, comma 2. Next element of 0 is 1. 1, comma -1, 1, comma 0, 1, comma 1, 1, comma 2. The next element of 1 is 2. 2, comma -1, 2, comma 0, 2, comma 1 and 2, comma 2. Now we see the total values of the ordered pair is 16. Each one row is 4. 4, 8, 12, 16. Is given n of A cross A is also 16. Okay. So these are the total values of A cross A. But we find the elements of S. Okay, we don't find all the values. We find the remaining values of S. Now we write the set S. But how to define S? The value of S is ordered pair A comma B belongs to first of all A cross A. We write the ordered pair A comma B belongs to first of all A cross A, but it satisfies one condition. The condition is the first element is always less than the second element. A is less than B. So yes, we write all ordered pair, but all the ordered pair lies only in A cross A, and also it satisfies the condition. The condition is the first one is less than the second one. A less than B. Therefore, now we write the values of S. Now we will take the suitable values of S. But A cross A contains 16 values. But all values we don't need. We need the ordered pair. The first one is less than the second one. So the suitable elements. I take the suitable elements. You see, both are same. So I leave. The element is not less than S. Second one is possible. Because the first one is less compared to the second one. This one is possible. -1 is less compared to +1. -1 is also less than 2. Possible. This is possible? Impossible. 0 is big compared to -1. This is also impossible. This value is possible. And that value is also possible. Next, this value is impossible because 1 is big compared to -1. This value is impossible, and this ordered pair both the same is impossible. This one is possible. 1, 2. Here, impossible, 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 and also it is impossible. So now that tick, okay, we tick some ordered pair. This is only possible in our require S. So the elements of S first I write. The values of S is -1, 0, -1, 1, -1, 2, 0, 1, 0, 2 and 1, 2, 0, 2 and 1, 2. So these are the values of S. So totally 1, 2, 3, 4, 5, 6. But given the two ordered pair -1, 2 and 0, 1 belongs to S. Is already given. This two ordered pair is belongs to S. Now we check these two elements is lies here -1, 2, 0, 1 is already less. Therefore, our question is to find the remaining elements of S. Therefore, the remaining elements of S are, we already two elements is given. So the remaining elements of S is first of all -1, 0, -1, 1 is we already write the 0, 1, 0, 2 and 1, so these are the remaining values of S. We check one time. In S contains means first of all ordered pair lies in A cross C. Okay, it's all the ordered pair lies in A cross C. And also it satisfies the first one is less compared to the second one. -1 is less compared to 0. -1 is less compared to 1. 0 is less compared to 2. 1 is less compared to 2. So these are four ordered pair is the remaining elements of S. Okay students, now we see the problem of contains exercise 1.1. The same model sum lies in example also. We must try in our classroom.